So as you know, I am Eli the Computer Guy, and today's class is on how to build a computer. So today's class, I'm going to show you how you actually put a computer together. So you take all the parts and throw it together, and you've got a working system. This is really incredibly simple. Like, by the end of this class that might be an hour at the most, you're just going to be dumbfounded that Michael Dell made billions of dollars simply by doing this. That you don't need a master's degree, you don't need a bachelor's degree, you don't need a high school education, and frankly, maybe if you have a kindergarten degree, you should still be able to do this. Building a computer is really pretty simple. It's paint the dots, paint by numbers. You just, if you know what parts to buy and if you understand what you're doing, it is just incredibly simple to do. You don't need any special tools, really. All you need to build a computer, the only thing that you need in your toolbox is a Phillips head screwdriver and then something called thermal paste. This is called Arctic silver. We'll talk about it when we're building the computer. But this is all you need. All you need to build a computer is a single screwdriver. You don't need special tools. You don't need multimeters or soldering irons or any of that. Building computers are just very, 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 very simple. Seriously, they are. So give me a second to get prepared, and we'll go in and I'll show you how to build your own computer. So now, I'm Eli the Computer Guy. I'm all for the geeky stuff. I'm all for the technical stuff. I'm all for getting your hands into the electronic gadgets. But as you also know, I am a pragmatist. So before we go into this class, before you decide to build your own computer, I just want to take a moment to talk to you about why you would want to build your own computer and why it might be better just to go over to Best Buy and pick up whatever they have for $300. Now, back in the day, 10 years ago, 5 years ago, 3 years ago, there was a huge profit margin when you built a computer. So, when I started my business, I could put one of these computers together entirely from getting all the parts to having the operating system on it in 2, maybe 3 hours, and for that I was looking at a $300 to $400 profit. So that was worthwhile. Computers were about $1,000 for a decent computer, and I could put together a decent computer for $600. So yeah, a few $100 profit is worthwhile, and even if you're not trying to sell computers, that's enough of a discount that it's worthwhile to build a computer yourself. I mean, everybody would like to save a few $100. But nowadays, the price of computers has dropped to the point where, I can't say that it's necessarily worth it anymore. Even before I closed my shop, we had stopped building custom computers because the profit margin simply wasn't there anymore. So before you decide to build your own computer, because you'll think it'll be cheaper, just realize it probably will not be. We're going to put all the hardware into the computer today to show you how to build the hardware component. But remember, once you build the computer, you need to install the operating system. Well, when you go to newegg.com or tigerdirect.com, when you go to buy an operating system CD for your computer, what you're going to find out is that the basic Windows 7 operating system costs approximately $100 or more. So think about that. Just the operating system costs $100. So if you go to the store and they have some eMachine or some Dell or whatever for $300, well, for you to create a computer like that, $100 alone will go to the operating system. So that means you only have $200 left to buy the parts. So, depending on why you want to build a computer, it's many times nowadays, it's just better just go to Dell or go to Best Buy. Now, why do I still build my computers? So I still, unless they're Macs, I still build all of my systems. Well, the reason that you should build your own systems is if you require high-end or specialty computers, because the main reasons is if you need a custom computer, well, you might as well just customize the entire thing. You can get exactly what you want. Or if you're looking for a high-end computer, so these are the desktop computers that are going to cost you $1,500 to $3,000, there is still enough of a difference on the profit margin that is worthwhile. So the video computer, the computer that I use for video editing, one, I needed to be customized, and two, it was very high-end with SATA 3 and solid-state drives and the whole 9 yards. So I still saved money off of building it myself. So that's something to think about. So that is a reason to build a computer for yourself. The other reason is if you like to upgrade a lot, building your own computer at the end of the day will be less expensive. So if you plan to go out and you buy new computers all the time, then you should just buy new computers. But if you're somebody who likes to upgrade, you can save a lot of money because you can reuse parts. So a computer case. So this is an ATX computer case. This is what all the guts will go into. ATX computer cases cost anywhere between $60 to $100, let's say. Well, these ATX computer cases have been around for 10 years. So if I had purchased a computer case 10 years ago, I could be using that exact same computer case for multiple different computers. So, I have one computer I put in there. After a year, I rip all the guts out, I put a new one in. After a year, I rip out the guts out, put a new one in. I don't have to keep rebuying the computer cases. So that's one place you save money. Again, $60 to $100. The next place is optical drives. They really haven't made a major upgrade in optical drives in 5 or 6 years at least. So if you have a DVD burner, you can continue to reuse that DVD burner. Like I say, this would be another $50. So simply reusing a DVD burner and your case, you're saving yourself $150 every time you rebuild the computer, build a quote-unquote new computer. If you can still use the same power supply, you can save yourself $100. If you can reuse your hard drive, you can save yourself however much this costs. So that's something to think about when you're trying to decide whether you should just buy a computer or build a computer. Basically, realize that you're not going to save a lot of money building a computer, and it may actually cost more to build your own computer nowadays if you're dealing with a low to mid-range computers. There's just no profit margin anymore. If you're dealing with expensive computers, and now these are Windows desktop computers that cost $1,500 or more, there still is a profit margin in there. If you do decide to build your computer, the argument for it is, like I say, is every time you upgrade your computer, you can continue to use old parts. You can continue to use the old case. You can continue to use the CD drive. You can continue to use graphics cards sometimes. So you can save a lot of money. So you get a brand new computer, but half the parts are used. Well, if it's cutting-edge computer, that still works. So I just want you to think about that, because, like I say, a lot of people think, oh, the only way they can go is to build their own computer. Real computer geeks build their own computers. And it's just not so anymore. If I was still in the computer business selling computers to clients, there is no way it's not worth the time to build computers for clients anymore. And like I say, for myself, the only reason I still build computers is because I'm dealing with the high-end video graphics computers. Otherwise, going to Best Buy, you'll probably be fine. So the question I always get, when customers come in or when new people decide to build their own computers, they'll say, Eli, so what do I need? What hardware do I need for my computer? And nowadays I have to say that's a very good question, and I have no idea. The best way to figure out what hardware you need for your computer is to find out or figure out what software you are going to be running on that computer. Are you going to be running Adobe? Are you going to be running Maya? Are you going to be playing whatever the Doom 5 video game is, whatever the latest and greatest is? And if you're going to be doing that, then really what you need to do is you need to go to any forum sites for that software that you're going to be using, or even to the websites for the software itself and see what they recommend, see what they suggest. Because if you go to Adobe, Adobe will tell you what hardware you should have. If like these video games now are so powerful that video game companies will tell you what type of hardware you should be running to run their video games well. On top of that, if you go to the forums and if you do a little bit of research, you can find what real users have used and possible differences in hardware. So they'll say, you know, use this motherboard versus that motherboard, and that's how you figure out what you need for your computer. If all you're looking for is some just middle of the road computer, you know, if this is just a hobby to figure out how computers are built or whatever, what I would suggest is when you go to newegg.com, just find decent middle of the road stuff. You know, find a $100 processor, find a $100 motherboard, find other basic parts and just put it together. Even low-end components now are actually really powerful. The lowest end computer that they're making is more powerful than most people need. Seriously, honestly. So if you're just looking for just a hobby computer to put it together, then you know, spend $50 to $100 on a processor, spend $50 to $100 on the motherboard, and then buy all of your other parts. You know, that's really how it is. If you're planning to build your computer again for Adobe or Maya or these video games, go to the manufacturer of the software, go to the forums and see what they suggest. Nowadays, these different pieces of software have so many different hardware requirements that what is good for Adobe may not be good for video gaming. What's good for video gaming might not be good for Maya. It's just how it is. These systems are now becoming more and more specialized, so you have to make sure that you buy the right parts and processors for the type of computer that you're going to be building, the type of applications that you're going to be using. Now, I've been talking about parts a little bit, and so I want to stress something. When you go and you decide to buy parts for your system, I want you to buy good quality parts from name brand manufacturers. Now, these name brand manufacturers may not be the name brands that you are used to, because you are used to dealing with Dell and you're used to dealing with Gateway, and they don't sell motherboards that you would know of. Companies that you should deal with. If you are going to buy a motherboard, buy an Asus motherboard or a Gigabit motherboard. If you are going to be buying a power supply, buy an Antec power supply. If you are going to be buying RAM, buy Kingston RAM. These are well-known, high-quality manufacturers of parts, of components. A lot of people try to go cheap when they buy parts for their new computer. And the problem is you know, you're trying to save money. And it's okay to save some money by building your own computer, but then you go too far by buying cheap parts for the computer that you're trying to build so you can save money. You know, the reason that Asus motherboards cost $50 to $100 and crappy motherboards cost $25 is because those crappy motherboards have a horrible tendency to fail. Just like when you buy a TV, just like when you buy a DVD, or just like when you buy a normal computer, these parts sometimes come to you dead on arrival, that they're bad. Well, the problem is, especially if you're new when you're building a computer, you don't know how to troubleshoot these things properly. You don't know if it's a bad power supply, or if you just did something dumb and the power supply is not working correctly. So if you buy these cheap parts, the chances are there's gonna be one or two of those parts in there that come to you dead on arrival, and then it's just a complete and utter nightmare trying to make the computer work. Not only that, but you should remember and know that if you buy low quality parts, in a computer, computers are electronic devices, and once you connect everything together, once you slot the power supply in and the cards, they all become one device. Well, these electronic devices, if there is a short or if there is a problem with the electricity going through one of the components, it can go through and destroy other components in the computer. So if you buy a low quality power supply, I've seen this a lot, the low power quality power supply dies, and you go, oh well, that's no big deal, I was buying a cheap power supply anyway. What you're not realizing is when that power supply dies, it can send a spike of energy that will go through, it'll destroy your motherboard, it can destroy your RAM, it can destroy your video card. So not only are you replacing this crappy little power supply, but now you're replacing your motherboard and your video card, etc. So all of these parts, when you put them together, become a whole, and if one of those parts in the whole is bad, it really, I'm not joking, I'm not being melodramatic. Like I say, you know, one of our fans just bought a power supply. It fried his system. He spent a lot of money to buy other good parts, and he skimped on the power supply, and that toasted his system. This happens in the real world. So the main thing is when you're thinking, what do I need for my computer? The question is, what software will you be running? Find out what the software manufacturers recommend, and then build your computer based on that. And then when you go to buy the parts, like I say, buy ASUS or Gigabit motherboards, buy Antec power supplies, Kingston RAM, buy good quality parts. I mean, it's just better. So let's go into a little bit of the planning phase. So the parts that you are going to buy for your computer, you know, based on maybe you need a special type of hard drive, or maybe you need a special type of graphics card, etc. What you should realize is everything runs through the motherboard. So this is the motherboard. This is what connects absolutely and everything together. So what you have to do when you're building your computer is you have to buy parts that will fit on and work in your motherboard. So once you're going to go out and you're going to decide on whatever motherboard you want. You know, it'll be $50, it'll be $300. You know, whatever it is, you'll decide on the motherboard that you want. The two parts that you cannot make a mistake on when you buy past the motherboard. So you bought the motherboard, then what you're going to need to buy is a processor for the motherboard. Now the processor that you're going to buy, it will either be Intel or AMD, and then it will be a type of processor. So there's something called the socket type, and the socket type is actually the shape of the processor that goes onto the motherboard. So 775, 771, etc. Basically, you have to buy a processor that will fit onto the motherboard, and that is the socket type. Beyond that, there's something called the front side bus. This is how fast the CPU and the motherboard can transfer information back and forth. And then there are the types of processors, Core 2 Duos, Xeons, Celerons, etc. Now, so you're asking, okay, so I figured out what motherboard I want. How am I going to figure out what processor? Well, basically, all you do is you go to the spec sheet, the specification sheet of the motherboard that you're buying, and you see what it'll accept. If it'll accept a Core 2 Duo at a 1033 megahertz front side bus, then you buy that type of processor. It's really that simple. Basically, when you look at the spec sheet for the motherboard, it will tell you what will fit on the motherboard. And if you buy what it tells you will fit on the motherboard, then you're good. If you buy something else, then it won't work. It's that simple. Also, it will tell you what type of RAM and what capacity of RAM that it can deal with. So RAM has different speeds. You know, there's DDR1, DDR2, DDR3, PC3200. There are different types of these RAMs. And so when you look at the spec sheet for a motherboard, it will tell you what kind of RAM it takes. So basically you go, oh, it takes PC3200. I'll buy a stick of that. It is literally that simple. Simply buy whatever it says the motherboard can handle. Now, nowadays, you know, computers are getting more and more RAM. You know, you can get 4 gig sticks of RAM, 8 gig sticks of RAM. The one thing that you should realize is most of these motherboards have a maximum amount of RAM that they will support. So no matter how much RAM you put in, they will only ever recognize whatever their maximum is. So most of these normal consumer motherboards only support 4 gigs of RAM. Even if you put 8 gigs of RAM in, and even if it works, the motherboard will only ever recognize 4. So just be careful with that. You know, some people go, I want 32 gigs of RAM, and they slot it in and the computer boots up, but the operating system will never be able to see any more than 4 gigs of RAM, or whatever the maximum is. So what you have to realize, you know, when you're going to buy your parts, is everything goes through the motherboard. So you know, it's got to fit on the motherboard. If you need a special type of video card for your Adobe or for your video game, you need to make sure that your motherboard has the slot for that type of graphic card. So, you know, PCI Express, no longer AGP. You know, make sure it has the slots that you need. And then, you know, you've got the CPU. So the specification sheet will show you what types of CPUs will fit on your motherboard. Just buy whatever they tell you to buy. And then the RAM, again, they'll tell you what the motherboard can take. Just buy whatever it is they tell you to buy. So, I mean, it's really that simple. I want to go, and we're going to go onto the computer, and we'll go to newegg.com, and I'll kind of show you how this process works. But like I say, it's very simple. It's easy it's easy as long as you paint by numbers. If you start being Vincent Van Gogh, it all goes weird. But you know, if you just do what they tell you will work, you'll be fine. Okay, so we're at the computer now, so I can show you how to buy all of the parts for your computer. So you're gonna need a motherboard, you're gonna need a CPU, you're gonna need RAM, you're gonna need a hard drive, you're gonna need an optical drive, and you're going to need a case. So the place that we're going to go to buy these parts is newegg.com, Newegg.com. This is the best place to buy parts if you're gonna build a computer. Really, most technology parts. They're incredibly fast, efficient, they're good quality, and you can't beat their prices. I used to have, when I had the repair shop, I used to have distributor relationships with, you know, real distributors, you know, people you had to sign contracts for and all of that. And I found they were not as fast, as good, or as inexpensive as Newegg. So I have used Newegg for years. Like I say, even running my shop, if you bought a hard drive from me at my shop, I had purchased it from Newegg because it was just that inexpensive and that cheap. So the first place that we're going to start is with the motherboard, like we talked about before. So we go up to computer hardware and we look for motherboards, and so we see motherboards. Now the first option that you're going to see is there are AMD motherboards or Intel motherboards. This is not the manufacturer of the motherboard, this is the type of processor that fits on the motherboard. So AMD is a manufacturer of processors and Intel is a manufacturer of processors. So if you plan to use an AMD processor, go for AMD motherboards. If you plan to use an Intel processor, go for an Intel motherboard. You know, they're not interchangeable. So what processor you're going to use depends on what you plan to use your computer for. AMD processors are usually less expensive than Intel's. You know, they're both good. I go with Intel, honestly, because most people know what Intel is. They don't really understand what AMD is. So, you know, the whole marketing thing, it's easier to sell what people think they understand. So I do Intel. So click on Intel. And so now, you know, you're going to be presented with lots and lots and lots of motherboards. There are 17 pages of motherboards, so that means they have about 400 different types of motherboards you can buy. So you will have to narrow down what motherboards you're looking for by using these search features. So you can search by manufacturer. So like I say, I like ASUS motherboards. So I will select ASUS, CPU types, front side buses, AGP slots, number of memory, PATA, SATA. I like the SATA 6 gigabits per second. This is the new standard for hard drives. So I'll select that, and then I'll just see what it tells me. So I hit search. So we see these are Intel motherboards that support Intel processors. They are ASUS motherboards, and they support the new SATA 6 gigabit per second standard for hard drives. There's different prices here: $139, $154, $189. These. Not all motherboards are made identical. There are different types of motherboards with different types of things on them. So what you spend on your motherboard depends on what you're going to need. Since I'm showing you how to do this, we'll just go with an inexpensive motherboard. So we'll click on this first ASUS. With Newegg, once you click on the item, it'll show you reviews. So these are honest reviews from people who have purchased the item. And then you can click on the specification tab right here, and this tells you the technical specifications for this motherboard. So things like the socket type. What socket type do you need to buy your CPU? What CPU type? So is an i7, an i5, an i3. So with this, basically socket type is the size of the socket, what the CPU actually looks like. And then the CPU type, this says that you should not buy a Xeon processor for this motherboard. A Xeon processor would not work properly on this motherboard. Then it tells you down here the slots for memory. So these are the individual memory slots. It tells you what memory to put in. So DDR3, 2200, 1600, 1333 or 1066. So it tells you specifically what types of RAM you can put in there. And then the maximum supported RAM, 16 gigs. So it will only ever recognize 16 gigs of RAM. So even if you put in 32 gigs, it just wouldn't recognize it. And then as you go down, it tells you the expansion slots: PCI Express 2.0, PCI Express 1, PCI slots, PATA, SATA. These are the SATA 6 gigabit per second, so you get 2 of them. These PATA, SATA, these are the connectors for your hard drives. So just keep that in mind. We'll tell you more about that when we go to buy a hard drive later. Onboard video, does it have a network card built into it? Yes, it does. It's a gigabit per second network card, and etc. A lot of other information. And then when we go to buy a case, see the physical specifications. The form factor is ATX. So this is a large motherboard, which means we need to buy a large ATX case for this motherboard. So the first thing that we're going to do is we are going to say we like this. Here, wait a minute. I think there's some stuff in the cart. So let me just kill all this. Let's remove selected. So we'll go back. And so we are going to say we like this motherboard, and so I'm going to add this to the cart. And so it is now added to the cart. We are then going to go back to this motherboard. Now what I'm going to do is I'm going to use something called tabbed browsing. If you know anything about modern web browsing, you can create tabs. So this is a tab that we're on. I will just keep this for the motherboard, and I will open a new tab to do searches for all the other parts. So what I'm going to do is I'll go to computer hardware. We're going to look at CPUs next. So CPU processor. I can right click and do open in a new tab. So we now have a CPU tab open, so we can buy CPUs. We'll go to processors desktop. So these are the desktop processors. We'll go to manufacturer. We will say Intel, just to get this down, because we know we're dealing with Intel processors. So now we're dealing with Intel processors. You see they start at $41, and Intel processors will go up to $2,000 a piece. So we go to the specification on the motherboard, and we see we need a socket type of LGA 1156. So we go over here, and we see CPU socket type LGA 1156, and we do a search. So this shows you the Intel LGA 1156 socket types. And then we go, and it says CPU type. So we can do i7s, i5s, or i3s. So, I want the latest and greatest and the fastest. So I'm going to say what i7 processors they have, and click search. And so now it shows me the two processors that it has that are i7. One is $279 and one is $579. So I can click on that. I see the reviews like before, sees the specifications. And so since the motherboard says LGA 1156 Core i7, this one will work for my computer. And so, you know, I look through it and go, okay, that looks good, so I add that to the cart. And so now I have two items. So now I have the motherboard and I now have the processor. Now the processor normally comes with its own heatsink. So the heatsink is, you know, what cools off the processor so it doesn't overheat. Some people decide to buy better heat sinks for their processor. It really depends on what you're planning to do. What I would suggest is if you're new to building computers, just use the heat sink that they gave you. If you run into problems, then buy a heat sink, you know, at a later time. But you know, these heat sinks, these additional heat sinks can cost anywhere between $10 to $100. So if you don't really know what you're doing, it's probably a waste of money to buy one. The stock standard heatsink that comes with a processor is usually good enough, at least in the beginning. So now we've got the motherboard, now we've got the processor, we need to go looking for RAM. And so this says it supports DDR3 2200 overclocking, 1600, 1333, or 1066. Overclocking is something we'll need to talk about later. That's kind of where you push the hardware faster than it's theoretically supposed to go. I generally suggest that people don't try to do overclocking unless they really understand computers. If you've built 5 or 6 computers and you're very comfortable building computers, by all means deal with overclocking. If you don't even know what overclocking is at this point in life, do not do overclocking. So it says DDR3 2200 OC. I would suggest you stay away from that. You should buy DDR3 1600. So that's what we will look for now. So we'll go to computer hardware, go to memory, we'll go to desktop memory, and what we're going to do is we're going to go down to speed, because that's what it is, and we're going to go DDR3, and what did it say? DDR3 1600. So we go to speed, DDR3 1600, and so we just select that, and then we hit search. And now, once DDR3, this is all the DDR3 1600 RAM that shows up. Now the main thing that you have to decide is what manufacturer you want to buy and then what size. So this is a 1 gig stick, Kingston 1 gig stick. Our thing supports, 16 gigs of RAM, so we'll go to capacity and we'll say, we'll just buy the 16 gig pack. So we'll do search. And so there's G.Skill and there's Kingston. Kingston is out of stock. G.Skill is another good manufacturer of RAM. So when you buy this package, you get a total of 16 gigs of RAM, but it's when it says 4 by 4 or 2 by whatever, this is 4 sticks of 4 gigs RAM. So you get 4 gig sticks of RAM. You know, if this looks good to you, don't go overboard on the price. You know, this is $729. It doesn't have to be that expensive. That's for, you know, all the RAM you can possibly buy. If you go down here to this Kingston 1 gig of RAM, that's only $35. So that you guys don't stress out, let's only buy 1 gig of RAM. So you guys are comfortable. I know if you see $730, you're all of a sudden never going to build a computer. You can buy it for $35. So we will click on this RAM. You know, we'll look at it. We'll go, yep, that looks nice. And so we'll buy that RAM. And so now we go to cart, we have the motherboard, the RAM, and the CPU. Now these are the most important parts to buy. If you buy the wrong type of RAM, your computer's not going to work. If you buy the wrong type of CPU, your computer's just not going to work. You know, there's no jury rigging, there's no super glue, there's no duct tape. It just simply will not work. So these are the most important parts to buy. And as I showed you, this is paint by numbers. All you do is you decide what motherboard you want, and then you just see what it will accept. Like I say, if you buy DDR3 1600, it will work. If you bought DDR3, I don't know, 800, it won't work because, you know, it doesn't support that. So now that we have the RAM, the motherboard, and the CPU, let's go and buy a hard drive. This particular motherboard supports SATA hard drives, so it supports both 3 gigabit per second, which is the standard hard drive that's been around for about 5 years, or the new SATA 6 gigabit per second that just came out this year. I like the 6 gigabit per second because it is faster. So what we're going to do is we're going to go back to computer hardware. We're going to go to hard drives. We will go to internal hard drives. And then again, you just plug in the information. So the interface is SATA 6 gigabit per second. And so we do a search. And this shows us the 4 hard drives that are SATA 6 gigabit per second hard drives. There's one for $80 all the way up to $250. You just look at this. If you like the specifications, great. If not, find another one. We're going to like the specification, and we're just going to hit add to cart. So now we've got hard drive, RAM, motherboard, and CPU. Now we need an optical drive. So we're going to go to optical drives. So it'll be CD. It'll be CD, DVD burner, and media. We will go to CD, DVD burners. And then basically we're just going to select something. If you get a modern motherboard, it will only have SATA connections for hard drives and optical drives. So you have to make sure that you get a SATA optical drive. So you'll see there's IDE or SATA. So we go for SATA and we hit search. And it gives you all these options. I like Lighton drives, but there's Sony, the whole 9 yards. Now, when you buy these optical drives, you're going to see something. They'll say either retail or OEM. You have to be careful when you're buying these, because what OEM means is when you buy that optical drive, all you're going to get in the mail is the actual optical drive. You see this drive right here? You're going to get that, and it's going to be taped in bubble wrap, and that's all you get. You don't get any of the CD burning software. You don't get the DVD playing software. So if you plug this into your computer, you will technically have a DVD burner, but you won't be able to burn 2 DVDs because you won't have the right software. So always make sure, especially when you're new, that you buy the retail version, because the retail version actually comes in a box like you would buy at Best Buy and has all the software and everything else that you would need. So let's just... We'll just go down, SATA. See, these are OEM. All these really cheap ones are OEMs. And then we get down to... Oops. Search. OEM. Okay. So this one right here is not an OEM. So we look at it, SATA connection, etc. You look, you can have pictures, so you see that you actually get a box and you actually get the software. That's very important with the DVD, the optical drives. And then you click Add to Cart. So now that we've done that, let's look. So we've got the hard drive, the optical drive. Now we need a case. So we're going to go back to this motherboard, and we need to look for what is called the form factor. That's what it says here. It's ATX. So ATX, what this means is this is the actual size. This is the physical dimensions of this board. So obviously you cannot put a motherboard into a case if it is bigger than the case. So you have to make sure that the motherboard will fit into the case. So you have ATX, mini ATX, and micro ATX. Smaller motherboards will fit into bigger cases. Bigger motherboards can't fit into smaller cases. So since this is an ATX motherboard, this is the largest type of motherboard, and therefore you need the largest type of case. All we do is, again, we go back to parts. We go down to computer cases. We get computer cases again, and then what we're going to do is see type. This is where you say what type you want. So there's ATX desktop, ATX full tower. These are the 2 types that we'd be looking at. A mid tower or a mini tower would be too small. Micro ATX would be too small, and this thing called mini ITX would be small. Remember, the size of the motherboard has to correspond to the size of the case. So we will go for ATX full tower, and we'll click search. And then, I mean, you've just got an insane number of different manufacturers of these cases. It all depends on what you want. Do you want clear sides? Do you want neon lights? Do you want 1,000 fans? It's whatever you decide. I like a company called Cooler Master, so I'll see what Cooler Master has. They have a lot of different types of cases. Again, they go from Cooler Master's low expensive, but they go for anywhere from $25 to $500 you can spend on a case. Let's say I like this Cooler Master case here. It's kind of stylish. It's got the black stuff, got handles. All you do is you just add to cart. So we've got the case, we've got everything other than the power supply. So we're going to go and we're going to take a look. At the power, and so physical specs, and it'll say power pin, so it's the normal 24 pin. The one thing with the power supply that you probably want to do is, one of the tabs on Newegg is you can go to manufacturer info, and then you can go to the manufacturer product page. So this is the actual product page of the manufacturer. Sometimes these motherboards require very powerful power supplies. Like I say, the computer that I use, or the motherboard that I use, required a 600 watt power supply. So sometimes you have to go to the specification page of the manufacturer to make sure you can buy the right power supply. Let's see, USB, features, overclocking. Okay, it doesn't seem to say it needs any special one, so we will just go and we will buy our power supply. So click, and we hit power supplies. And then here, again, you just have a crap load of power supplies. The big thing is how much wattage. So this is the actual power of the power supply that you're going to be using. This is how much oomph it can put out. If you're new to building computers, I would actually say buy high. If you know what you're doing building computers, then buy as low as possible. Like most of my computers run off of 380 watt power supplies. But again, like I say, this big Uber computer that I just built required a 600 watt power supply. For you guys, why not? Just do a 600 watt power supply. Because that way, if you're overpowered, your computer will still work fine. If you're underpowered, yeah, it's not going to work at all. It's not even going to turn on. Now you're going to see once you do this that there are a lot of different manufacturers of power supplies. As I will tell you, you do not want to buy cheap power supplies. Cheap power supplies can do just massive amounts of damage to your entire system. I would suggest you go with this company called Antec, A-N-T-E-C. These make very, 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 very good power supplies, high quality power supplies. When you buy a power supply, buy a good high quality power supply. Click on it. It'll give you, again, the normal overview, specifications, etc. And so if it has everything you like, you simply click Add to Cart. And that's it. So with this basic computer that we just bought all the parts for. So we have the motherboard. Motherboard is the most important part. Then we bought the CPU and the heatsink. Then we bought the RAM. Then we bought the hard drive. Then we bought the optical drive. Then we bought the case. And then we bought the power supply. So all of these components should work very well. And then you see the total price for this one is $814. Now the one thing to remember with this is don't forget about your operating system. Once you build the computer, once you have it, it needs an operating system to work. So if you already have, either a hacked operating system or you have a real operating system, CD, that will work fine. If you use Linux, that will work fine. If you don't have those, make sure you just go and buy an operating system while you're here. You just go to Software and you go to Operating Systems. Once you go here, you can see, they've got Home Premium 64, these are $100, Windows XP if you wanted to bother with that. So let's just say we want a Home Premium 64-bit OEM, we just add that to the cart. So now we have absolutely everything that we need, and we would just go through the checkout process. Now, when you're brand new to building the computers, the one little piece of advice that I would give you is always give yourself a cushion for the price of buying all these parts. It's really easy to buy the wrong part by accident. You click the wrong thing, and for most of these parts it's too expensive to ship them back, because remember, if you return a part, they're not going to refund you the shipping that it costs to ship it to you, and you're going to have to pay for shipping it back to them. So you're going to end up spending anywhere between $10 to $30 to return a part. So it's usually not worth it. So just give yourself a cushion of an extra $100 or $200 when you're first building computers, because the chances are that you are going to buy a wrong part, and that you're just going to probably have to eat the cost of the wrong part. Kind of sucks, but that's the way it is. But really, I mean, that's all there is to speccing out and buying the parts for your computer. If I actually wanted to buy this computer, I would just click buy, and I would buy all these parts and build it in the 2 days when it came to it. So now that you've seen how to go about buying parts for your computer, let's go back out to the real world, and I will show you how to put all these parts together. So the first thing that we need to do is we need to put the CPU, this is the CPU, the central processing unit. We need to put the CPU onto the motherboard. And this is best done before you do anything else. So a lot of people decide to put the motherboard in the case first, and then put in the CPU, but it's really easier to do this when the motherboard is outside of the case, especially basically for plugging in the heatsink. Now you will notice I'm just kind of like touching all this stuff willy-nilly, and you've probably heard of something called ESD, or electric static discharge. This is static electricity that goes in and fries computer components. And yes, I will tell you as a professional, that is something you should definitely be worried about. But I'm not worried about it too much. It's one of those things, it is real. Theoretically, you should be worried about electrostatic discharge, but I'm not. I've been doing this stuff for 12 years, and I don't think I've ever killed a component. But it's something to think about. So what we're doing, so we have the motherboard, we have the CPU, we have what is called the heat sink. This goes on top of the CPU, and it dissipates heat. If the CPU gets too hot, it will shut down automatically. The reason is because if the CPU gets too hot, it literally can melt itself. So I mean, it gets hot. It gets hot enough to boil water. So you need to put what's called a heat sink on top of the CPU so that it cools down. And then finally, to connect the CPU to the heat sink, you use something called thermal paste, which is normally a brand called Arctic Silver. Basically, this is a weird, it's like a glue or a paste with metal fragments in it, and it connects the CPU to the heat sink in such a way that the heat transfers better. If you don't have any thermal paste between the CPU and the heat sink, the CPU can still overheat. So this is like this and the Phillips head screwdriver are the only tools you need to put together a computer. One of these little syringes for probably 20 or 30 computers will cost you $7 on Newegg.com. So this stuff is not that expensive, but you do need it. So what do? We grab the motherboard, as so, and then on the motherboard, you have a little door mechanism. So you kind of just pull this down, and then you open up the door, and that allows you to put the processor onto the board. Now with this, remember, these are very delicate parts, so you have to make sure that you put the processor into the motherboard the right way. It's kind of stupid how they did it. These processors are squares, so it seems like you could put it onto the motherboard any way you want. Well, they have little guides you can use. I don't know, can you see those little circles or half circles right there? Those little guides show you how to put it onto the motherboard. So you line those little half circles up with the little half circles on the motherboard, and you put in the processor. Make sure you put in the processor the right way. If you don't, and you crank down on this door, you will destroy the processor and you will destroy the motherboard. But once you put it in properly, all you do is you close the door, and then you close the latch, And that's it. Now the processor is on the motherboard. Literally that simple. So now that you've done that, you need to put a little Arctic paste compound. I don't know, all the little 15-year-old experts out there have all kinds of things about how much you should put on. I just put a little dollop on it. So you just put a little dab will do you. I don't know if it's too much or it's too little, but I don't have overheating problems on my computer, so I'm not too worried about it. So I put about that much on there. And then once you do that, you grab your heatsink and you put that onto the board. Now this, putting the heatsink onto the board is what I call a thumb buster. It's because it really kind of hurts your thumbs to do. I don't know why they've done this. It seems like there should be an easier way to put a heatsink on a board, but the way that the manufacturers have made it, it really kind of hurts your thumbs to put it on there. If you're like from my generation, think of it like Nintendo thumb. It just hurts. So you line up the heatsink so it goes on, and then you see these little buttons here. You push that through so it connects to the motherboard. So you click, 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 and then finally click. So all four. So you do it in a diagonal. You do one here, and then you do the one here. You do one here, and then you do one here. That's how you secure it down. The next and final thing that you do, so you don't lose your mind, is the fan on the heatsink has to be connected to the motherboard. There's this little electrical connection. All you do is you look on the motherboard, and there will be one little connector, and it'll say CPU fan. So you just connect this to the CPU fan connector, and then it's all good to go. This is something like even I forget about sometimes, and seriously, if this fan is not working, the computer will not do a lot of stuff. It may not even boot up because it doesn't want to fry the CPU. So if you forget to plug this in, you may have a non-functional computer for something as simple as this, and then you're spending 2 hours trying to figure out what's wrong with your computer. So that's what you do to connect the motherboard. Since the motherboard's out and it's easy to do anyway, I'm going to put the RAM in. So the RAM sticks, as you should know by now, just look like this, no big deal. So in order to put a stick of RAM into your computer, you just line it up. Notice, see how that there's a middle divider, but the middle divider isn't really in the middle. This allows you to line up this RAM stick properly into the slot. So you just line it up properly and then push down really hard. And so when you push it down, these little ears here need to click in and make sure it's secure. So this should be secure on. Everything has to be secure on this motherboard. And so now this is a motherboard with the processor, with the heatsink, and with the RAM on it, which is really just a huge part of this job. Now, once I put this into the computer, it's going to get a little hard to see some of these parts, so I want to show you something right now so that you see it and realize that it exists. These little plugs up here, these are for where the power plug and the reset button and little hard drive LED get plugged in when you put this into the case. So you'll have on whatever motherboard you have these line of pins, and then you put you connect these little connectors for, like I say, the power switch, the reset button, the hard drive button, etc. So that's where those are. Now, before I put the motherboard into the case, one thing you'll notice is that this case, this seems more open than normal. So this is about where the motherboard will go, and it seems that seems very open. Well, the reason that is open is because all motherboards use something called a back plate. So this back plate goes into the case right here, like this. So for some reason, and this can be really confusing to new people, is cases always come with a generic back plate that looks something like this, but is not quite like this, and therefore will not work properly. So when you buy your motherboard, you will get a back plate that looks like this. If your desktop computer or your case has a back plate already in it. You need to push it out. You need to punch it out and then put the new back plate in there. Because like I say, they give you a generic back plate with the case. I don't know why, because it's never fit any motherboard that I've ever put into a case. It's just one of those funny things. So realistically, if you want to put the back plate in, like I say, you got this. You got like a little frame around this. All you do is you take this, you slot it into the back from the inside, and then you just push it in. Now I'm showing you, this was very easy because I'm using used parts, but sometimes you might have to kind of push it in there with a screwdriver. Sometimes it can be very difficult. That was very easy, but it can be really just a pain in the butt to push it. Again, Nintendo thumb. Now the next thing, this case is nice enough to have something called risers already built in. What risers are, do you see these little metal things right here? These are little posts that you screw the motherboard into. So sometimes these risers are already on the case when you buy it. Other times, for some reason, they're extra little parts that you have to screw into the case. You need to screw them in because it gives a lift for the motherboard about this high. If you try to screw the motherboard straight onto the case, it's just going to be bad. It doesn't fit properly. And like I say, a lot of people overlook this because they don't realize it. So never screw the motherboard directly to the case. There are always going to be risers, either built in, or like I say, they just give you a packet of them and you screw them onto the motherboard, and then you screw the motherboard onto those risers. So the risers get screwed into the case, the motherboard gets screwed into the risers. Make sure you do that. So now that we've done that, let's bring you over and we'll start building this computer. Da-da-da-da. So now we've got the case and we have the motherboard. Now what we need to do is we need to slot this motherboard with the processor and everything into the case. So all you do is, these are the stuff on the back panel. You just line this up with the back plate, as I talked about before, and you just kind of slot that in. Again, this is I'm using used parts, so this is a little easier than it may be for you, but that's really all you do. And then you grab your screws and you just screw the motherboard down to those risers that I talked about. So there's a little screw here. There's a screw over here. And there's a screw up here. So that's really all there is to screwing the motherboard onto the case. So now the motherboard is part of the case. So once we do that, now we need to put in the optical drive. So let me go get the optical drive. So when I talk about the optical drive, I'm talking about the CD drive, the DVD drive, the Blu-ray drive, etc. Now in this case, it's very nice because you can just slide the drive in. So you just take this, I already have the hole open, and you just slide it in, and then you lock it into place. You don't need any screws for this one. And now the drive is at least on the case itself. And then the next part is putting the hard drive in. So now this hard drive here, as you should know, it is a SATA hard drive, and it has these little rails that connect to the side of it. So these rails, you just clip onto it, and then you can slide this into the hard drive carrier. So now we just slot that in there. And now the hard drive is in the case. So we've got the motherboard, CPU, RAM, hard drive, optical drive, etc. in the case. And then the final thing for right at this moment will be the power supply. So the power supply that you're putting in. All you do with the power supply is you line it up properly. It just goes in. And then there are 4 screws on the back of it. And you just screw them in from the back. For some reason, power supplies almost always get screwed in from the back. I've never seen a power supply get screwed in from the side or the bottom. There are always 4 little screws on the back. That's just how it is. Okay, so now we've got the power supply in. You know, since I'm doing this anyway, I'll just throw in my fancy graphics card all at the same time. Again, very simple to do. So I've got it's called a PCI Express graphics card. And all you do to slot in the graphics card is, you see this slot right here. This is a PCI graphics slot. You just take it and you push it down into that little slot. And then with all of these cards, you have to make sure is you're always able to put 1 screw in just to secure it. So you slot it into the slot and then you secure it with 1 screw. And voila. So right now, all of the hardware that needs to be in this computer is in this computer. Again, so we have the motherboard, we have the CPU, we have the heatsink, we have the RAM, we now have the graphics card, we have the power supply, we have the optical drive, and we have the hard drive. See how simple that is? That's really simple to do. Now, what we need to do is just actually start connecting all of this stuff together within this case. Now, the first thing that we need to do when we're connecting all this stuff together is connect all the stuff from the front of the case. What I mean by this is this means the power button, the reset button, the hard drive button, etc. Now, in order to do that, again, on the motherboard, I showed you the pins before. A lot of times these pins are marked and you can read them straight on the motherboard. Other times you actually need the manual for the motherboard, and the manual will tell you. It all really depends. But basically, so we have a reset switch here. So I just go down and I look and I say, where is the reset switch? And it shows me where the reset switch is. And then we have the power switch. And so I look down here and it tells me where the power switch is. And I plug in the power switch. And then, you know, they've got other stuff I don't really care about. The power LEDs. And then you plug in the power LEDs. And that's all you do. So these are the power buttons, the reset switch, and all that. That now plugs into the motherboard. Now, on top of that, you have the front USB connections and the front audio connections. All you really have to do is, if you notice, this is a very distinctive type of plug. So you just basically look for a plug that looks like this on the motherboard. And so if I look down, there's the audio plug, and all I do is I connect that right down there. And then you push it in. And that's done. Now these are the front USB connectors. And so I look for the front USB plug, and I plug that in, which is right there. And now that's all it is for plugging the motherboard onto the case. Now, what we need to do is we need to start plugging the power supply into the places the power supply needs to go. So the first thing is this mamma jamma honking power connector. So this power connector, you need to look on the motherboard and see where it goes. So this big guy has a big port right there, and you just plug this into it. That plugs into it. And then you have another connector that goes to the motherboard. This is the plus 12, it's called the plus 12 volt. And this goes over, there's a little plug over by the CPU. And this gets plugged into it. And now the power supply is connected to the motherboard. Now all you need to do is you need to connect the power supply to the optical drive and to the hard drive. Now these are both SATA, S-A-T-A, hard drive and optical drive. So you use the SATA power connector. And so you take that and you connect that here. Take the other one, and you connect that here. And voila! That's now the power supply is all connected. There's no more connections for the power supply. The last thing is to actually connect the optical drive and the hard drive to the motherboard. So that's where you need these SATA cables. These are SATA hard drive cables. So one side goes up and connects to the optical drive. And then you look on the motherboard and there's SATA connectors. Oops, if you can see them right down there. And you just connect it in. It doesn't really matter which SATA connector you connect these into. So you can connect the hard drive into whatever you want, the optical drive into whatever you want. It doesn't really matter. And then that goes into the hard drive. And that goes on to the motherboard. So literally, we have in I don't know, however long this took, about 20 minutes, we have put all the hardware together for this computer. Now, if you're using other types of specialized hardware, you know, there may be some extra stuff you have to do. Some video cards require their own power connection. You know, if you're using SCSI or SAS hard drives, they have their own configuration. But those are incredibly specialized things that you're probably not going to run into for a while. But this is how you build a basic modern computer. So, you know, you got the power supply, optical, the whole 9 yards, and that's really it. I mean, all you do from here is you slap the side on this desktop computer, and it's ready to get an operating system put into it. So let me straighten up a little bit, and I'll talk to you about the major problems that most people run into when they start building their computer. So that's it. This entire computer has been put together. If I've done everything properly, you know, I just put a power cord in the back of this, plug in a monitor, keyboard, mouse, and I'm ready to install an operating system. Really, that's all there is to it. Now, there are common mistakes that cause problems, and these are things that you should know about. So if you plug the computer in and it will not turn on, there are a few reasons for that. Now, the first reason is, if you look at the back of the computer, if you look at the power supply, there are two potential problems right here. One is most power supplies actually have a power switch on the power supply itself. So if this power switch is turned off, no amount of pressing the button in the front will make this thing turn on because the power supply itself is turned off. The other thing is all of these computers are built to either accept 1 to 15 volts or 220 volts. So either US voltage or European voltage. Sometimes that little switch in the back gets knocked one way or the other. So if you look on the back of that power supply and it says 220 on a little red switch, shove the switch over so that it says 115. That's what the US uses. If it says 220, basically it's just not going to work properly. You get this problem also a lot. We had a problem with cheap power supplies where that little switch would just kind of knock back and forth with the wind. Like literally, if somebody tapped it with their foot, it would switch over to 220 and the computer would shut off. It wouldn't work right. So that is a problem you can run into with a power supply. The other major problem that people deal with is these little cords I was showing you, the connectors that go from the motherboard to the power and the reset button on the front. Those things can be really finicky, and there's just little pins in there. You have to make sure that you get those pins correct. Even me doing this for 12 years, throwing a computer together, a lot of times I'll mess up and I won't put the power switch onto the right pins. So make sure that those pins are proper. Now, if the computer still will not boot up, the next thing that you should do is it's called reseating everything. What reseating means is you pull out the RAM and then you stick it back in to make sure that the connection is done properly. You pull off the CPU and the heatsink and then you put it back on to make sure the connection is proper. You pull out the connectors for the hard drive, plug them back in and make sure that the connection is proper. For some reason, this fixes an atrocious amount of problems. I don't know why, but simply just pulling things out and plugging them back in a lot of times fixes the issue. Now, if you're still having problems, you may hear a beeping in the background. Be very quiet, and you might hear like beep, 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 beep. Something like Morse code, almost. That is something called BIOS error beeps. So the BIOS on the computer is the lowest level operating system. Well, it tries to detect everything. So it tries to detect the hard drives. It tries to detect the keyboard and mouse. It tries to detect the CPU. It tries to detect the RAM. If it doesn't detect those things, a lot of times it will give a beep for an error code. And if you have the manual for your motherboard, you can go, 3 beeps in a row means the RAM is bad. And sometimes that will show you what the problem is. But yeah, that's really all there is to building a computer. So let me get a couple things cleaned up, and then we'll have some final thoughts on this. So that's really all there is to building a computer. You know what? In 15 minutes to half an hour, you can throw all these parts together and have a system that is ready for you to install the operating system on. If we press the power button, you hear everything whir up, and everything's working now. So that is literally how easy it is to build a computer. And now remember, when I'm talking about building a computer, some people may be thinking, well, that's a desktop computer. What about a server? What about a media center computer? What about a digital surveillance computer? What about a telephone system computer? It's all basically the same stuff. Depending on what the computer you're building is going to be used for, you may have a few specialized components. Like if you build a telephone system computer, you will need a card to go into that computer that actually accepts telephone lines. If you build a digital surveillance system computer, you will need a card that goes into the computer that accepts video cameras. But it's still a motherboard, a processor, a heatsink, RAM, hard drive, etc. There are specialized parts out there, and if you're building a computer that needs one of those specialized parts, just do a little bit of research, 5, 10, 30 minutes worth of research, and you'll understand how to install it. I mean, it's really that easy. So, this computer here, you could put Windows XP, Windows 7, Windows 2008 Enterprise Server Edition, Linux, basically anything other than Mac OS, could be installed on this computer. This stuff is really, really, really that easy. Now, I talked about in the beginning buying parts. The main thing with making sure that your computer build will be successful is make sure you buy the right parts. I showed you how to go on to newegg.com, look at the spec sheet from the motherboard, and then basically, like I say, just paint by numbers. If it says it accepts DDR2 RAM, buy DDR2 RAM. If you buy DDR3, it's not going to work. It's that simple. Just buy what that motherboard will accept. If you do that, it's easy peasy. Again, buy good quality parts. I have to bang this into so many people's heads. It's not worth saving a few dollars buying cheap components. The first thing is most of these components, when they come to you, if they're cheap by no-name manufacturers, they have a huge number of defects. I mean, literally, I've seen up to 50% defects where, you know, I had to build a computer lab. I bought 10 motherboards and 5 came dead on arrival. This kind of crap happens. So it's not worth the time and energy to buy these cheap components. It's not. Not only that, but remember that when you put these parts together, they become part of an electrical system. So if there is any problem with one component in that system, you risk the chance of damaging other components in the system. Again, power supplies are a big culprit, but I've seen it with things like motherboards. The power supply sends a surge because it's dying. You know, the power supply dies. Oops, oh well. Well, but the power supply, when it died, sent out a surge of electricity, fries a motherboard, fries a video card, maybe even fries a hard drive. Simply by putting an inexpensive, you know, cheap, no-name power supply into your computer, you could literally fry every single component in that computer. And is that worth 20, 30, 40 bucks that you're saving buying some cheap power supply? I don't think so. And then the one part that I didn't talk about, making sure you buy a quality part of, but you should, is the case. A lot of people, again, if there's one thing that they think they can skimp on, they go, oh, you know what I'm not going to spend money on? I'm not going to spend money on a case. I don't care what my computer looks like. I just need a metal frame to put all these parts in. It's fine not to care what your computer looks like. But just like the motherboard and the RAM and all of that, the manufacturers, the cheap manufacturers of cases really make some crap. And you know, I showed you how easy it is. I love these cases. These cases are made by Cooler Master, and they're very easy to shove all these parts into. Some of those $20 and $25 cases are a nightmare. Parts aren't square when they're fitted together. So like when you go to put the optical drive in, the DVD drive, you have to like shove it in there. You have to bend parts of the metal just to get it to work right. Being able to open up the case can be a pain in the butt. You know, just parts don't fit. And so when you go to build the computer, it's just a pain, because you're going in there with a pair of pliers and having to bend metal sometimes just to get the motherboard to fit right. So again, I would say it's not worth it. You know, spend 50 bucks and get a decent case, and you'll be good. Now, you know, as with all these classes, you know, talk just not about the technical part, about building computers, but I want you to have a greater aspect or greater thoughts about the IT industry. And one thing with building computers is I really want you to think about is look at this. You know, this took 15, 30 minutes. You know, on a bad day, this would take 30 minutes. You know, if I'm hungover and have the flu, it would take 30 minutes to build this thing. Throwing an operating system on there, depending on what process I was using, would take anywhere between an hour to maybe 2 hours, right? So 2.5 hours from this going from parts to a fully functioning computer. I want you to realize that 3 years ago, that would have been $200 to $400 in profit. So I would have made anywhere between $200 to $400 simply by putting this together, putting an operating system on it. And that's before I dropped it off. It's before I installed it. Just building it was $200 to $400. 5 or 6 years ago, it was $500 to $600 profit. 10 years ago, it was almost $1,000 profit simply to put a computer together. And it has gotten no easier in 10 years to put a computer together. What I showed you is basically how you've been putting computers together since something called 386 days. I mean, it's always been that simple. The thing is, people were willing to pay a lot because they were scared of the technology. They thought it was more complicated than it was. You know, for whatever reason, they were willing to pay people basically $1,000. They didn't realize they were paying $1,000, but they were willing to pay $1,000 simply to have a computer put together. Now, you know, I don't want to cry in my beer or anything about the old days, but what I want you to think about that is think about the new technologies that people are willing to pay for. Think about that. So this computer here, 2.5 hours, at one time would have been $1,000 profit. I had a 19-year-old friend of mine making $100,000 a year when I was in high school by building computers, doing simply what I did. There is technology like that right now. Like I say, whether it's with building websites, people will spend $2,000 to $3,000 on a website you can build in 4 or 5 hours. web marketing, all these other technologies. What I want you to think about is, now that you understand how to build a computer, so you build your own computer, yay. But look for technologies like this that you can provide to your customers, your clients, or your boss that are available today. The social networking, websites, there's a bunch of stuff out there with the same type of profit margins. I mean, really, think about that. I'm not joking. For what I showed you, I used to pull $400 profit. And that was before I charged the people to install the computer into their system. So simply building a computer like this and setting it up, it used to be $600 or $700 in profit. And that type of profit margin is still available if you're willing to go out there and look for the products that people are willing to buy. Yeah, like I say, just the bigger picture on this and something to think about. Again, as a computer geek, as a technologist, if you want to build your computers, you should still build your computers. It's best to build your computers if you need something highly specialized, or if you're like me, you're going to be swapping out parts all the time anyway. But don't feel like nowadays you have to build your own computer, or that you're going to save a lot of money building your own computer. As I said, I can go to Best Buy right this second and buy a laptop computer, a laptop, not a netbook, a laptop for $130 or $330. I can buy a desktop computer for between $200 to $300. When you go out to build your own computer, you're going to see that the operating system itself, if you buy a Windows operating system, is going to be at least $100. So there's no longer the markup in building computers. There's no longer, you don't save a whole lot of money by building your own computer, and you may not be able to build it for as cheap as they can sell it. So just keep that in mind. It's like, if you feel like the only way to save money is to build your own computers, that's not so anymore. Just go out and buy a Dell or an HP or whatever they got at Best Buy. If you want to build your own computer, it's because you either need something that's really customized, or again, something really high end. If you're going to spend $1,500 to $2,000 simply on the desktop computer itself, then it might be best to build your own computer. But well, I hope you learned a lot. I know this is one of the popular topics. Everybody wants to know how to build computers. So I hope you now understand how to build it. It is that simple. Don't overthink it. They don't need any soldering irons. Don't need any of that. You need Phillips head screwdriver, and you need Arctic Silver thermal compound. That's all you need to build a computer. As you know, I'm Eli the Computer Guy, and I look forward to seeing you at the next class.